very common question is, if I have a open front split, how can I get a true front split? So even ballet dancers who use an open front split still frequently would like to get a true front split. Okay? So let's see how we can convert one thing to the other and see where the problems might be. So, for instance, so Sasha can do an open front split. Right? So this is an open front split. What does that mean? That means that the rear leg is turned out, one leg in front, one leg in back, but the rear leg is turned out. Okay? So we're simulating because Sasha can do a turned out or a squared or a true front split. She can do that as well. So please go ahead and do that. Okay? But there's a lot of people who cannot. They can do an open front split, they cannot do a true front split. So we want to see where an issue is. In other words, is it the front leg, is it the back leg, which muscles is the problem? So let's go back to the open front split one more time. So we're here. We know that for the front leg, especially if she's turning forward, her medial hamstring is flexible enough, and if she's slightly turning to the side, we know that it might be her lateral hamstring. Okay? So that's how we take a look at the front leg. For the back leg, we know that her adductors are flexible enough, and we know that all the muscles that want to turn in, but they turned out, they're also flexible enough. So the adductors are flexible, pectineus is flexible, tensor fasciolaris is flexible. The muscles that might present a problem are psoas, of course psoas together with iliacus, also sartorius, and also rectus femoris. Because these muscles like to turn out, and in true front split you have to do the opposite and be turned in. So let's take a look. We're going to lie down in the back. Okay. So we're looking for the lateral hamstring. So let's say this is as far as she can go. This is as far as she can go. She has 90 degrees. That means that the other leg would be required 90 degrees. Otherwise, she cannot do a true front split. However, we know that for the open front split, she would be able to go more in this way if I brought the leg out to the side. Okay? But let's say, in this case, we're going to test her hamstring to see, and she can go here, let's say, or here, for example. So we want to measure this angle, how much she has in the front leg and how much she needs in the rear leg. Okay? So I'm going to measure here. Okay? So please assist with your hands. Okay? We don't want this hip to rise. And we're going to measure. This is about 150 degrees, 149 degrees, but I'm going to say 150 degrees. Okay, which means that to do a functional true front split, she only needs 30 more degrees in the hip. 30 more. That's all she needs. If she wants a structural, then it doesn't matter how much she has here. She needs 90 in the front leg, 90 in the back leg. For most people, that's very hard to get. But functional, which means that the legs are apart, although most of that comes from the front leg, it's still a true front split. It's functional, is not complete in structure, is not 90-90, but it works. Okay? So in this case, she would only need 30 more degrees from the back hip. Okay? So let's get into the lunge position, and we want to measure the lunge position in such a way that we do not use the back. We just do the hip flexors. So the leg comes forward, hands go here. By locking the elbows, we know that once she's here and she starts going forward, her body will remain vertical, and she's not going to move from her spine or compensate with the other leg. It's going to be purely the back leg. Okay? So remember, all we need is 30 degrees. Now, if she can do an open front split, she cannot do a true front split, then we know that She doesn't have those 30 because we just checked 150 in the front leg. Okay? So she's going to go forward just a little bit. Let's say she's staying right here. Okay? Okay, so this is 53 degrees. Okay? 53 degrees. Now, if she is somewhere here, let's say a little bit more, and she has very tight hip flexors, this is 18 degrees. Okay? So let's say you measure yourself, and this is your case, you're at 18 degrees. Well, what's getting in the way? The muscles that I just listed, all of them are lateral rotators. So let's see if that's the case. If I'm going to turn out, okay, this muscle should be getting out of the way and she should be able to go more in. And if that is the case, then I know that those specific muscles are the problem, which is the sartorius and iliopsoas. We know that the rectus femoris is not the problem because she's going all the way in with a bent knee, and the bent knee is compensating for that turnout. Okay? So if that's the case, then what we do is test the psoas and the sartorius, maybe both of them problem, maybe one, and just focus on those because I know that her hamstring is way too flexible and we don't need anything there. So let's take a look at a different case scenario. So same thing, so Sasha is going to lie down on her back, and this is a different person now, okay? This is a different person. And we're testing the hamstrings again. So leg comes here, right? This is as far as it goes, okay? For a structural front split, this is all she needs, okay? Because she has 90 in the front leg and she needs to get 90 in the rear leg. But for the functional one, this is where she is. We know that it's much easier to get a little bit more flexibility here than to get that flexibility from the rear leg. In that case, if this is where she is, we would also focus on the hamstring. And if we bring the leg out to the side and comes here, we know that the medial hamstring is fine, the lateral hamstring is tight, especially if she's here, but the second we come over and turn in, the angle becomes less. In other words, it's not 90 anymore, we turn in and come over, and it's not 90, but it's less. In that case, we would also work on the hamstring, especially the lateral hamstring. So I hope this helps. Thank you for watching.